Hello everyone, today we're going to be talking about different types of angles. First off, let's start with what an angle even is. The definition of an angle is the space between two intersecting lines or surfaces at or close to the point where they meet, usually measured in degrees. There's that. The definition I like to personally use is the amount of turn between two connecting lines. Notice how I underline certain words to help you out. So let's start with drawing two lines up on the board. So I'm going to go ahead and draw two lines. So notice these lines aren't connected. In our definition it says the space between two intersecting lines. Well, we have our two lines, but they're not intersecting yet. In order for them to be intersected, that means they have to be touching. They need to meet. So in order to intersect them, they need to be meeting at their ends. So we can do one here and meet them together at the bottom. I'm going to erase these two. The second part of the definition says, or close to the point where they meet, usually measured in degrees. So right here, this is the intersection like we just said. So I'm going to label that over here. Intersection. And I'm going to make it darker. The space between two intersecting lines. So this space right here is what our angle is. So the way we want to label our angle is going to be like a part of a circle. That angle right there. But there's a trick that we're going to learn about in a second when we talk about our different angles. So now that we know what an angle is, I can go ahead and teach you guys the different types of angles, their names. So we're going to talk about three different angles. So our first angle is the one that we just drew. It looks like a big L. It's called a right angle. So a right angle you can make with your arms, just make a big L. Second one we're going to talk about is an acute angle. The way I like to learn about the acute angles and teach is, you know, when your grandma comes and pinches her little cheeks, she goes, "Oh, you're so cute, da-da-da-da-da." You're going to take your fingers like this, like you're about to pinch your own cheeks. "Oh, what a cute little angle." So we have acute angles. Acute angles. Just go like this. So we have a right angle, or your hand, and we have such a cute little angle. And the final angle we have is an obtuse angle. So obtuse angle are really, really big. They're bigger than a right angle, and they're bigger than acute angle. So when we say obtuse, the way to remember is just say it really big. So we're going to go obtuse angle. And that's how you can remember them. So now I'm going to go ahead and write the words for you. So we have our acute. We have our right. And we have our obtuse. So, quick review. An acute angle is such a cute little angle, so that means it's going to be really small. Now that we know our angle is that space in between our two intersecting lines, and this is where they met. Our right angle is an L. So we're just going to draw an L. And our obtuse angle is going to be really big. So we can make it like this, like that. That's going to be our obtuse angle. Now that we have our pictures and our labels, we remember that this is a vertice. This is where they intersected. These intersected right here. These intersected right here. Are two intersecting lines on each angle. Remember, our angle is the space in between also. So how do we know how much it is? For today, we're going to know our base amount, which is always going to be with your right angle. With a right angle, you always label it with a square on the inside. And our base amount is going to be 90 degrees. That's our degrees symbol. like it states in the definition, usually measured in degrees. So if our 90 degrees will always be a square, no matter where you see it, it'll always be marked with a square, or you'll know to mark it with a square. Our acute angles are a lot smaller than our right angles, as you can see, because our acute angles are what? They're such a cute little angle, so it's gonna be less than 90 degrees. Now our obtuse angle is so big, it's bigger than our acute angle, it's bigger than our right angle, so that means it must be greater than 90 degrees because it's such an obtuse angle. So when we mark our angles, the space inside, that's our angle. Here we're going to do that. We already know this one's marked because it's a square, meaning it's 90 degrees because it's a perfect angle. And then this one's going to be so big. Another way to remember these, if you get confused, is the A in acute. It already makes such a cute little angle. See how my fingers resemble that picture I drew? Such a cute little angle. So we have our A, and it looks just like that also. Our obtuse has a big O in the front. So obtuse angle. You have your O. So now we're going to do something different. I'm going to draw a picture of a pizza because everybody loves pizza. It's not going to be perfect. So we can see where we see angles in every single day of our lives. So I'm going to divide this pizza into different pieces. They aren't going to be perfect. And there's our pizza. And it's divided into 8 pieces. So within our pizza, we can already see there are a couple acute angles in every slice. Let's measure a couple. So we have one right here, one here. We can go all the way around. So that's one example where you see acute angles. You can also see them over here. It almost looks like a right angle, doesn't it? But it's not really a right angle yet because pizza's curved on the outside. It's not straight. That's not how it happens with pizza. Fix that. So we have acute angles all over the place, right? So now I want to add some toppings on our pizza. So we're going to add some pepperonis. Just going to do some circles for some pepperonis. Next, let's add some cheese. Every pizza has cheese. We're going to make rectangles as our cheese. Some cheeses are bigger than others. That's okay. And our next topping we're going to add some peppers. I like when my pizza has peppers on it. We're going to make our peppers into triangles. Just add them all over the place. Now that our pizza looks really yummy, making me hungry, we're going to dissect it and we're going to look at each individual ingredient. So again, we have our circles, which are pepperoni. We have our, let's do it again. We have our rectangles, which is cheese. And we have our triangles, which are peppers. We're going to move our ingredients over here so we have some more space. Let's start with our peppers. So this is a triangle. Right off the bat, we can see there are no right angles because there aren't any squares and nothing that looks like an L, like a perfect L. So we can automatically assume that these are acute angles because they're pretty little. So let's mark all those. And even if we take it apart, even though the definition says 2 intersecting lines, there can be more. So it could be these 2 lines that met, these two lines that met, or even these two lines that met up here. You can see it in your shapes every day. Even if we made this into a diamond, these could still be intersecting, or these two could be intersecting right where our angles are. That's space. So this was our peppers. Next, I'm gonna draw our cheese. We're gonna make it really big so you can see all the angles. Well, if we look at it, we see a couple right angles in here, don't we? Since we know they're right angles, because squares and rectangles have perfect edges and perfect connections where they intersect, because these two intersected here, these two intersected here, these two intersected here, and the last two intersected here. Since we know they're 90 degrees are right angles, and we write our right angles with squares. So every single corner is going to have a square. Even if we chop it through the middle, it's still going to be a right angle here, 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 here. Let me show you something different with our cheese. So if we take our cheese again, we can make our cheese into two triangles, which can give us different options of angles. So let's say we cut it right down the side. We no longer have a right angle here. It was chopped up. So now we have acute angles and right angles. Acute, acute. Now I'm going to take one pepperoni. Our pepperoni is pretty similar to our pizza, except it wasn't chopped up into anything, but I'm going to chop it up so we can see different things. So right now there's no angles. There's no lines that are meeting, nothing like that. But if we, let's say I want to cut it like that. The lines that I just wrote meet right here. This is the little dot. Now this angle is way bigger than an acute angle, and it's even bigger than a right angle. So that means it must be an obtuse angle, greater than 90 degrees. But then if I wanted to cut it right here, that is an acute angle because it's so cute and it's so little. So that is less than 90 degrees. So as we take a final look at our pizza, we see acute angles. When we look at our cheeses, we see right angles. So all these angles are everywhere. This isn't just in math, this is in real life too. And even if I were to take, let's say I put these two slices back together. Let's fix where they intersect. They're vertices right here. Right here there's a right angle, right? Because it makes an L. It's not acute and it's not obtuse. So it makes an L, and that's a right angle. You can mix and match it however you want, but here's an example of everything put together. Now let's have a quick review over what we learned today. So we have different angles. The angles is the space between two intersecting lines. So this right here is the space. This angle specifically is obtuse because it's so big. There's a big O in the front. Obtuse angles are greater than 90 degrees. We have our perfect angle, which is an L, measures 90 degrees. You should always know it's 90 degrees when you see that square in the corner. Only perfect right angles will have a square. Then we have our acute angle because it's so cute, and that's a little angle, and the two lines met here, these two lines met here. Acute angles are less than 90 degrees. Remember, this is your degree symbol. Now that we know what our different angles are, we have our acute angle, our right angle, and our obtuse angle. So next time we will be able to measure them. Since we know some are over 90 and some are below 90, we'll be able to know exactly which ones And I hope you start noticing all your angles around you. Have a good day.